Hello and welcome to this quick review of oxidation of alcohols. It should be used alongside your independent study notes, and it looks at oxidation reactions using potassium dichromate in acidified solution as the oxidizing agent. It doesn't cover combustion of alcohols, but they would technically also be classed as an oxidation because you'd be burning the alcohol in the supply of oxygen from the air. So let's first of all look at the oxidizing agent in this case. So first of all, an oxidizing agent is something that removes electrons from another species and itself is reduced. So obviously the other species in this particular case is going to be the alcohol. So I'm going to start by constructing what's called a half equation for this oxidation. But what I'm going to do is take it from the point of view of the dichromate. So the dichromate ion is Cr2O72-, and it turns into Cr3+. So in terms of what you would see, your dichromate is an orange solution and the Cr3+ is a dark green solution. We'll come back to what it would look like in reality a little bit later. So if we assign oxidation numbers, we can work out that the chromium in Cr2O72- is going to be +6. Now this isn't a balanced equation as it stands, so we have to think about what's going to happen. If it goes from +6 to +3, we need to think first of all how many chromiums are there. There's 2 on the left hand side, so we need to put 2 on the right hand side. So if you go from +6 to +3, that's a gain of 3 electrons, but it's happening twice. Now you'll see that there's 7 oxygens on the left hand side, so they have to go somewhere as well. So if you have 7 H2Os, you need to have hydrogens on the left hand side to justify that. So that's where you've got 14H+ coming in, hence why it has to be acidified. So that's our complete equation, and the electrons will come from an alcohol and the hydrogen ions will be provided by the acid. So let's now have a look at some examples of how this might work. So let's take propan-1-ol as an example. So propan-1-ol is a primary alcohol, and I've also labelled up the type of functional groups present on each of the others. So each highlighted section is basically the functional group that's present in that particular structure. So when we have an oxidizing agent, we put it in as an O in square brackets. And because this is a reagent, it can go above the arrow in the equation. So you might also spot that it's not entirely balanced in places. So for example, going from propan-1-ol to propanal, you're removing a water molecule. So in the first oxidation in each case, you'll also get a water molecule produced. So let's now have a look at how this might be drawn in a sort of equation form. This is like a reaction scheme. Let's have a look at an equation. So this example would be the oxidation of butan-2-ol to butanone. So it's a secondary alcohol, just like propan-2-ol is, and it would make a ketone, in this case butanone. So again, propan-1-ol, just like the one up in the top of the page, this time I've drawn it out as an equation, and you've also got the conditions, so you distill it. Now I'm going to be talking about that in a second, how do you distill, how do you reflux, and what do you get if you do each of those techniques. So if you were to take the aldehyde section, for example, you'll notice that that doesn't produce a water this time, so this is the second oxidation. If I highlight which one this would be, in the reaction scheme at the top. Okay, so let's now look at the conditions. How do we do this in the lab? So you'll have come across both of these before, hopefully. Distillation is being used for isolating the aldehyde, so the aldehyde ends up in the conical flask, and reflux is for going all the way, full oxidation, to carboxylic acid. So you could also use the reflux technique to oxidize a secondary alcohol to a ketone. And if we go back to the distillation equipment, that could be used for isolating the aldehyde from the oxidation of a primary alcohol. Okay, so that covers most of the parts of the syllabus for A-level that you need to know for oxidation of alcohols. Let's have a look at an exam question to see how this sort of might come up. So there's several different ways they could ask about the oxidation of alcohols. They could ask about the equations, but what they don't always do is ask about practical skills. So I thought I'd cover that because obviously in the current specification you could get this asked about in a 6-mark question. But let's have a look at how it might be asked in a normal structured question. So on the left of the page it gives you two diagrams. You can obviously see reflux and distillation, and it's using acidified potassium dichromate solution to form either ethanol on the left hand side or ethanoic acid on the right hand side. It gives you some data as well about the boiling points. So it says use the table of boiling points to explain why the organic product is likely to be ethanol if the apparatus shown in figure 1 is used. Let's have a look at that first. So the ethanol has a lower boiling point compared to ethanoic acid, and therefore it will be removed or distilled off first. Now we need to think about the second one. So the second picture, figure 2, why the organic product is likely to be ethanoic acid if the apparatus shown in figure 2 is used. So the first thing to do is complete oxidation will occur, and then the second thing is that the components of the products can't escape. So as long as you have those ideas in slightly different words maybe, but the idea making reference to what happens to the ethanoic acid, and in the first one making reference to what happens to the ethanol. Then it wants a balanced equation for the oxidation of ethanol to ethanoic acid and use O to represent the oxidizing agent. So remember there are two oxidations that take place. The first one is to ethanol and the second one is from ethanol to ethanoic acid. So you have your ethanol on the left hand side, two oxygens from the oxidizing agent making ethanoic acid and water. Okay, the final thing we have to do is look at what you would observe in terms of the change of the colour of the oxidizing agent. Remember we said earlier that the dichromate ion is orange and the Cr3 plus ion is dark green. So it's worth pointing out that the green colour you see is the Cr3 plus, and the orangey yellow colour is the original Cr2O72 minus. So with primary alcohols you get oxidation to an aldehyde. With secondary alcohols you get oxidation to a ketone. And looking at the oxidation product of the primary alcohol, you can also get further oxidation of that aldehyde to a carboxylic acid. Okay, so that takes us to the end of this clip. Hopefully it's covered most of the things that might come up in your A-level type questions. So once again, thanks for listening, and until next time, see you soon.